Okay, today we start a brand new unit, Unit 5. We have some prereq topics we're going to cover before we get into the meat of the lesson. And this first prereq topic has to do with Pythagorean theorem and its converse. We talked about this last unit. A right triangle has exactly one right angle. The opposite side from that right angle has a special name called the hypotenuse. The other two sides are called legs. Those sides that are called legs are the two segments that meet in a perpendicular. And what the Pythagorean theorem says is if ABC is a right triangle and AB is the hypotenuse, then AC squared plus CB squared is exactly equal to AB squared. So if we look at how this is applied in the example, we take the two sides that make the right angle. Those are the two that go together with the summation, and then the hypotenuse is all by itself squared, and we fill it in, and then we solve for whatever we need. Again, we know that the square root of x squared is the absolute value of x. However, again, because we're talking about measures here, it would not make sense to put that x could equal -5. So here we set this one up. We have x squared plus 8 squared is equal to 16 squared. X squared is 16 squared minus 8 squared. X would be the square root of 16 squared minus 8 squared. Got a nice calculator? Do it all at once. You get x equals the square root of 192. We want to practice using our simplest radical form. So we look for the greatest perfect square divisor of 192. That happens to be 64. So x is equal to 8 square root 3. I have 3 squared plus 4 squared equals x squared. 9 and 16 give you x squared. X is the square root of 25. X is 5. This one here actually is special, along with this one here. These two are Pythagorean triples. Okay, sometimes we have the right triangle figure, sometimes we do not. Here we just have to pay attention to which letters represent which sides. It says that C is the hypotenuse, so that's the one that always has to be left alone. So I'll have A squared plus B squared equals C squared. Solving for B squared, 15. B squared is equal to 15 squared minus 11 squared. B is equal to the square root of 15 squared minus 11 squared. B is equal to 2 square root 26 when we simplify it. Here we're missing A squared plus B squared equals C squared. A squared is C squared minus B squared. When I have the square of a square root, I just have the number. A is the square root of 10. 16 minus 6. Ooh, and let's make sure I put on my units here. This is representative of yards, and this is representative of meters. Excuse me, the converse of the Pythagorean theorem. Remember, converse switches the hypothesis and conclusion. It says, if A squared plus B squared equals C squared, then we know that we have a right triangle. So if we apply this one, we've done something similar when we had the converse of another theorem last unit. We don't put that these are equivalent. We set it up and we put the question mark. And one thing that I like to do to distinguish this from the Pythagorean theorem is I like to kind of flip it around. And I put the hypotenuse first, then my question mark, and then my A squared plus my b squared. And then I have is 256 the same as 100 plus 2 times 2 times 39. 256 the same as 256, and the answer is, yeah, those two things are equivalent, so this is a right triangle. And you want the biggest side, okay, the one next to it looks like should be the hypotenuse, the longest length by itself. You have 11 squared. Is that equivalent to 9 squared plus the square root of 115 squared? So it's 121, the same as 81 plus 115. And I have 121 does not equal 196. So this is not a right triangle. And we can do the same procedure without the picture of the triangle. We just have to make sure that the side that stands alone is always the largest length that we are given. So I have 15 squared. Is that equivalent to 9 squared plus 12 squared? It's 225, equivalent to 81 plus 144. Yes, 225 is exactly equal to 225, so the given lengths produce a right triangle. Take this one, we have 2 square root 2 squared. How does that compare to 2 squared plus 2 squared? This is 2 times 2 times 2. How is that equivalent or not equivalent to 4 plus 4? 2 times 2 is 4 times 2 is 8. 4 plus 4 is 8, so given lengths do create a right triangle. I'm going to copy some stuff, not make it over. It's okay. Okay, so we're looking on the school playground. The slide is 12 meters due west of the tire swing and 5 meters due south of the monkey bars. Determine the distance between the tire swing and the monkey bars. And our hint here is always to sketch our triangle and label it before we try to apply the Pythagorean theorem. So we start with slide being due west of the tire swing and due south of the monkey bars. We label, we see these two sides here are the two legs of the right triangle, so that is how we set up our Pythagorean theorem. 5 squared plus 12 squared equals this distance we're looking for squared, and solve for C. So we would have something like the square root of 169 as C, and that is 13. So the monkey bars are 13 meters from the tire swing. And this one we have to produce our own sketch. Carson is about to ride a straight water slide, so that's just like the old-fashioned slides. Launching platform is at the top of a tower that is 8 meters tall. The splash pool is at the end of the slide is 15 meters from the base of the tower. Determine the length of the water slide. Again, our hint is to sketch. We always want to start with the ground. Some of us did not do that last unit on our test when we were drawing our shadow problems. Remember, the shadow's always on the ground, so stuff is going to come from the ground. So here's my 8-meter tower at which the slide begins. And then here's the pool of water that you splash into. And the distance from the tower to the pool is 15 meters. Now that I have my triangle set up, I'm going to write my equation applying the Pythagorean theorem. 8 squared plus 15 squared is x squared. Probably should put the x on the drawing also. And then I have 64 plus 225 is x squared. X is going to be the square root of 289. X is equal to 17. So the water slide is 17 meters long. Okay, this last little bit is to complete. You are to craft a problem using the Pythagorean theorem, do the labeled sketch like we have here, and then show the solution.